Hi, we're here with Tom Spohrer from Microchip. And one of the things Microchip is really good at is coming out with good controllers for digital power supplies. And that's kind of what we have in this demo board right here. Tom, this new PIC controller, one of the things it's really good at is actually changing the algorithm in midstream when it's controlling even two different switching supplies. Can you tell us a little bit about what's going on here and what we're seeing on the display behind us?
Okay. One of the things our customers have asked for is the ability to change any of the firmware in their power supply because they don't know what might need to be upgraded in the field. But in these high availability systems, it's imperative that the supply not be taken down to make those changes. So with this new family of dsPIC DSCs, we've included the feature that allows live updating of any of the firmware. What we're demonstrating here is being able to update the compensator code specifically while the power supply is running. And so what we're showing on the scope here is the yellow line is the GPIO output that shows when we're making that transition from one set version of the code to another version of the code. The purple line here is the interrupt service routines for each of the two power supplies that's on this board. So we do a buck compensator calculation, then we do a boost compensator calculation, and those set up the PWM width of subsequent PWM cycles. And then after we've done that, we can make that transition to the all new code, which is a new compensator code in this example, and then get right back into new PWM updates using the new code to update the compensator.
Right. And one of the other interesting things about this is the speed of the power supply that this makes possible. Can you talk a little bit about that?
Well, in this case, we're running at a 350 kilohertz switching frequency, and we've got two outputs, a buck and a boost, all with the same DSC. And we're able to transition over to all new code and still not lose regulation at 350 kilohertz switching frequency. Great.
Is there any way to do that before this?
It just really isn't practical without hardware like this. And we're the first to be able to do that with a firmware-based device where you can change the compensator and everything else in that code.
Oh, great, Tom. That's a useful device for somebody designing a digital power supply.